Okay, this is our lesson on section 7.1. I intend to divide it into two parts. The first part of it, we're going to do 1 through 27 odd. We're going to be simplifying trigonometric expressions. On 31 through 47 odd, we'll assign those, and those are identities. Some books say prove identities, some say verify identities. This book says prove identities, and I kind of like using that terminology instead of verify. So we're going to do this now, and then when we finish that, then I'll do the second part of the lesson. I want you to look at your formula sheet. If you do not have the one I ran off, which you're going to be able to use on a final, there is the formula sheets also given in the book, and you can find this right here. Now, for the lesson we have now, we're going to be using fundamental trig identities, which are the identities above where my thumb is showing on this screen. So those are the ones we're going to be using. Now, some of them you already have memorized. I'm not going to make you memorize them. Some of them you'll use so many times you'll have them memorized anyway. However, you will use these so much, like I say, you're going to use them so much you're going to have some of them memorized, but we're not going to just memorize them for the sake of memorizing. Some of them we already know. Secant and cosine are inverse functions, so secant is 1 over cosine x. We could have just as easily said cosine x is equal to 1 over secant. Cosecant is 1 over sine. We could just as easily say that sine is 1 over secant. Cotan is 1 over tan. We just could easily have said tan is 1 over cotan. The problems, and we'll talk about these, are the right triangle, Pythagorean theorem on the ones in the middle. Some books talk about that, some don't. We won't worry about it. These are even and odd functions. Now, we've covered that. F of negative x equal negative f of x is an odd function. F of negative x equal to f of x is an even function. In trig, if you will notice, cosine of negative x is cosine of x. That's an even function. That would also indicate that the inverse of cosine, which is secant of negative x, would be equal to secant of x. And so even and odd functions at the bottom of this thing, and we'll be talking about that again on some of the problems we're going to work here shortly. Okay, look at your book and look at number 1. I'm going to talk about that briefly since you're responsible for it. It says an equation is called an identity if it is valid for, the word is all that you're going to plug in the blank, for all values of x. When it says that secant x is equal to 1 over cosine x, it makes no difference what I plug in for x. I'm going to have this side equal to that side. That's what an identity is. When no matter what you plug in for x, it's a true statement. The second part of that, sine squared plus cosine squared, you're going to be looking for a lot of these through here. Sine squared plus cosine squared, we look at our identities, we see that the answer is 1. Now then, I want you to look at problems 3 through 12, and I'm going to look at number 5. And it says, write the trigonometric expression in terms of sine and cosine and then simplify. Now, probably when I give a problem like this on the final, I'm probably going to pick one that we're going to talk about when we do identities. And you're going to already know the answer. But when it says simplify or when it says identities, if you do not have something jump out at you, you're going to hear that a lot. That's just my lingo. Unless something jumps out at you, you're going to change everything to sine and cosine and simplify. Now I'm going to repeat that again. Unless something jumps out at you, sometimes there will be an identity, it jumps out at you, and you can shorten your work quite a bit by using a simpler form that might not be in terms of sine and cosine. But if nothing jumps out at you, we're going to change everything to sine and cosine and simplify. So if I'm simplifying this one, I've got sine theta And I've got secant theta. Secant is the inverse of cosine, so that's 1 over cosine theta. Sine times 1 over cosine is sine theta over cosine theta. Look at your identities, and it should say on there that sine over cosine is tan theta. This is my simplified form. And let me look and make sure they put that on there. And they sure do. They have tan x is equal to sine x over cosine x. All right, simplifying. We're going to do it like this. Let's work another one or two. Let's look on down. Let's go to number 11. Now, sometimes in class, I get talking too fast. The nice thing about this is if I talk too fast, you can turn around and listen to it 3 or 4 times if you want to. Let's look at number 11. All right, we want to simplify that. And if nothing jumps out at us, nothing jumps out at me, then we're going to change everything to sine and cosine and simplify. Well, right now, this is already in sine and cosine, but this one is not. We know that secant is 1 over cosine theta minus cosine theta over sine theta. Now, guys, I'm working this. I'm going to put in every little step doing it. You know from past, anything you can do in your head in my class, you can do it in your head and you can shorten it by doing it in your head. I think I'll be able to figure out what you did. So don't worry about it. If you can do it in your head, shorten it and do it in your head. For this problem, I'm going to show every little step on here. All right? I've got everything in terms of sine and cosine. Now then I want to simplify it. Well, I see that in the numerator, have a fraction plus a number. I need a common denominator in order to simplify this. This is already over cosine. And I need to put this over cosine. So to put that over cosine, well, remember the way I'm going to do that. I got cosine theta. And I'm going to multiply it by form of 1. Remember, I multiply by 1. I'll not change its value, but I will change its form. So I'm going to multiply by cosine theta over cosine theta. Anything divided by itself is 1. Cosine times cosine is cosine squared theta over cosine theta. So I'm going to write this like this. Cosine squared theta over cosine theta. Now then I can add and subtract because I have a common denominator. My common denominator is cosine theta. And I've got 1 minus cosine squared. Now, if I was in class, somebody might ask me, well, you know, how do I do that? That's the same thing like 1/6 minus 2/6. Well, I'm going to take the 6 and put it in the denominator and then do the difference in the numerator. So I have this thing right here. Now, I want you to look back at your chart again, your formula sheet, and you will see on that formula sheet where it says that sine squared plus cosine squared is equal to 1. I'm going to come over to the side here. I'm going to write that in a little bit different way. I've got sine squared x plus cosine squared x is equal to 1. Which would mean I could subtract cosine squared from both sides, and I'd have sine squared x is equal to 1 minus cosine squared x. Now, by the way, this identity right here is used as much like this. Same way I could say that cosine squared is 1 minus sine squared. I could say that cosine squared subtracts sine squared from both sides. You're going to use this identity in this form or this form probably as much as you use it in this form. All right, so that being the case, I've got 1 minus cosine squared. 1 minus cosine squared we know is sine squared. So I have sine squared theta over cosine theta. If it's okay, I'm dividing by sign. Divide by sign means the same as to multiply by its reciprocal. To divide by 2 means to multiply by, is the same thing as multiplying by half. Dividing by sine theta is the same thing as multiplying by 1 over sine theta. I see that sine theta will go into sine squared theta sine times. So this gives me sine theta over cosine theta. And sine theta over cosine theta, if we look at our identity formulas again, we see that this is tan theta, and that is our simplified form. Now guys, again, there are many ways that we can simplify this as long as we're using an identity and a fundamental thing that we know in mathematics. Then we're going to be able, when I say fundamental thing, a fundamental operation we have, then I can simplify this. If I erase the board and work it again, I might work it different ways in here, but I'd still come up with tan theta. Again, you've got the odd numbered problems. The reason I give you odd numbered problems when you work a problem, I want you to be able to look immediately at the back of the book and see if you worked it correctly. Okay, let's do something else. Let's see what we want to work next. Let's work number 15. Again, multiple ways that I can work this. I could work up here a while and get it, or I can go ahead and work it in parts. I think I'm going to work it in parts. I got sine t over tan t, plus, and I have tan t over tan t, like so. Now, this is nice because I know that this is going to be 1. Over here, I've got sine t over, and we know that tan t is sine t over cosine t. I also know that divide means to multiply by the reciprocal, so I have sine t times the reciprocal of this, which would be cosine t over sine t, my plus 1 out here. All right, I see now that the sines will cancel out, and that will leave me cosine t plus 1 for an answer. Okay, let's do another one. Let's look on down. Let's do number 25. All right, now let me repeat myself just a minute. Just like the previous problem I worked, is that the only way I can work it? No. If you work it different than that, are you okay? Yes. The only thing is that any way we work it, when we get through, we need to have the same answer. So again, the problem I worked a while ago, I could erase the board, put it on the board again. I might work it different the next time. We'll work this one. The next time we do it, we may do it different. Now, I'll look at it and see if anything jumps out at me. Nothing jumps out at me. So I'm going to change all this to sine and cosine and simplify. Cosine, well, that's already in sine and cosine. Secant, we know that secant is 1 over cosine. And we know that tan is sine over cosine. How do we know that? It's on that formula sheet. That's one of our fundamental one of our fundamental identities in trig. It's in those first ones there that I gave you on the sheet. All right, now I'm going to simplify this. I've got cosine x over. I have a common denominator, therefore I can add the numerators, with the common denominator being cosine x, and that would give me 1 plus sine x, like so. All right, divide means to multiply by the reciprocal, so that gives me cosine x times, the reciprocal of that is cosine x over 1 plus sine x, like so. When I multiply this, I get cosine squared x over 1 plus sine x. Now, a while ago, I told you when you looked at your identities, you have sine squared x plus cosine squared x equal 1. And I told you we would see this thing more often where we're doing something like sine squared x is equal to 1 minus cosine squared x, or that we'd have cosine squared x is equal to 1 minus sine squared x. This is the one we want to use over here. Instead of cosine squared x, we want 1 minus sine squared x. The reason we want that is because we can factor this down. Now, I hope you recognize that that's a difference of squares. We all know that a squared minus b squared is equal to a plus b times a minus b. In this particular case, this is 1 squared minus sine squared. It is a difference of squares, so I can break this down to 1 plus sine x times 1 minus sine x all over 1 plus sine x, like so. We see a common factor in the numerator and denominator. We see that this cancels out, leaving us an answer of 1 minus sine x, like so, for an answer. Now, a lot of people do not really like these. You kind of wonder, well, when have I got it simplified? And when we get to the second part of this lesson, we're going to do identities. And basically, when we do identities, we're going to already have the answer like this, and we're going to work this side until we get that. I suspect that you're going to enjoy identities a lot more than you do simplifying, because that's going to be like a puzzle. You're going to know the answer before you start. We're going to know that this is the answer, and then the job that you have is working this until you get that answer. That's going to be the second part of the lesson. We're going to stop for now, and then I'm going to pick back up with the second part of the lesson.